Okay, on example 8, we're going to put a bunch of stuff together. So we learned vertical translation, so up, down, shift. We learned left and right shift, horizontal translations. We learned the scale factor or dilations, the fact that it can get compressed vertically and stretch, or it can get flattened out and get compressed vertically. The last one that we learned about was the reflections, and that's when you see a negative sign either in the front of a parentheses or within the parentheses on the X. So here it's important for you to describe each piece and see how many things are happening to your graph. That way you make sure to hit each one. In this case, we are doing a up and down shift. We're going to go down -2, so down 2. We have a left and right shift, which is a -1 here. So we are going, instead of negative on the 1 to the left, we're going to go right 1. Remember, it's opposite if it's in that parentheses. We have a flip, a reflection across the x-axis. That's the negative on the 3 out front. We also have a vertical shift on the 3 because it's outside of the parentheses. Okay, so there's 4 things that are happening on this one. Very, very important. It does matter the order in which you do these. The pieces that have to go first are the reflections and the stretches. So any sort of dilations that you have. So reflections and dilations go first. So here we go. And once again, I'm using my finger, so we're just gonna hope for the best. So they could have given us a bigger graph, but there's our original. So I'm gonna go ahead and do the flip, and then I'm gonna do, actually let's do the scale factor first. It doesn't matter which one you do first, but I like to look at my points in the positive area, and then we can flip it over. So remember, we are dealing with 0, 0, 1, 1, 2, 4, and we're changing those 3 and then mirroring them on the other side. So if we have a 3 shift, you can go ahead and either multiply all of your y's by 3 and then actually like physically flip it down. Or what you can do is multiply your y's by a -3. And what it's going to do is it's going to flip it already because you're doing a negative number. So we're going to actually do that all in one step here. Okay, here we go. So I'm going to erase those 3 numbers, 0, 1, and 4, and I'm going to multiply all those numbers by a -3. So the 1 is swapping out, the 4 is swapping out, and I'm going to do -3 times 1, which is -3, and -3 times 4, which is -12. And I can tell you right now, the -12 isn't even going to show up on our graph. So technically, we're only going to have 3 points, but we can kind of eyeball where it would go if it did go somewhere. Okay, so let's go ahead and flip over these points. So 0, 0 stays. I'm going to erase the 3 that we have, or the points that we have, because I know that we already found our new ones. So 0, 0 stays. 1, -3 goes down to there, and I'm going to go ahead and flip it. And then 2 and -12, I don't even have enough space because this is a 6. And then I'm just going to like put it down here and down here. And I'm just going to remember that that's supposed to be a -12 in case it jumps back on our graph. Normally, what I would have you do is draw a bigger graph so it can fit all the points. Okay, so now what we can do, we did two of our shifts in one step. Now I can go ahead and shift up and down, left and right. So the down 2 is pushing the -2 in the back is pushing the graph down 2. The -1 in the parentheses is not pushing it to the left, it's pushing it to the right because it's opposite. So I'm going to go right 1, down 2 for all my points. So let's do a final shift. 0, 0 is going to go right 1 down 2 to there. And I'm going to go ahead and do each piece. I'm not going to follow my pattern this time because we had a shift. Normally I would just do the 1 1 and then the 2 4, but I'm going to go ahead and count each dot. So right 1 down 2. Ooh, there we go. And then same thing for the other point, right 1 down 2. And it pushes our 12s that are off the screen or off the graph down further. So I'm just going to ignore those, and I'm going to go ahead and sketch in what I do have. I'm off by a little bit, but that's only because I'm drawing it with my hand. Okay. So let's describe what's happening here. It says the graph of the parent function. Wait, g of x is the graph of the parent function, x squared. X squared is the original. We are reflecting across the x-axis and translated down to left 1. Sorry, no, right 1. We went right. And there we go. So that's how you do a combination. Do the reflections and the scale factors first, or the dilations, and then do the ups and downs, rights and lefts next.